are going to solve question number 235, lowest common ancestor of a binary search tree. It's a pretty easy question. It's not a medium level question, really. First, we need to understand what is the lowest common ancestor. So, lowest common ancestor will be, suppose we have input as 2 and 8. For 2 and 8, my lowest common ancestor will be 6. So, why? Because 2 is also linked with 6 and 8 is also linked with 6. That's why the first link was 6 only for both. That's why it is a lowest common what you call ancestor. In this case, you can see 2 and 4 is there. So 2 is linked with 4 and 4 has a parent 2 and 2 can be ancestor of its own self also. So 2 and 4, the answer will be 2. See, we have an answer 2. Okay. The thing is, this is a binary search tree, so it's pretty easy to traverse through it. How? Let's just see. Uh, so first, base condition every time condition. Yep. What will be the base condition? Okay. If root is null, then answer is null. Okay. Now first thing which we need to see. If suppose P is greater than, suppose P is greater than what? P is greater than root and Q is smaller than root. If this will be the case, it means 6 is here, 2 is smaller than 6, 8 is greater than 6. Then obviously our least common ancestor will be the root because there will be no value in the left side which will be greater than 6 and no value in the right side which will be smaller than 6. Obviously, that's what the condition says. That's how binary search tree works. So just let's write it. So if p dot val is greater than equals to also because one can, so because this node can also be ancestor of its own or you can say descendant of its own. In the question they have mentioned it. Okay, so in that case, let's just do this. And q dot val is more than equal to root dot val, then we will return root. Okay, but one thing more, vice versa. If we see vice versa means q is greater and p is smaller, then also we have to return root only. Okay, so this was the one thing. Now comes the traversing part. Recursively traversing the tree. Okay, what will happen? Suppose in my left subtree, suppose uh, both, suppose both p and q were smaller than root, then I need to search in the left subtree. So what I will do? Let's just copy this code again and like this. If my P and Q both were smaller than root, then I will return what I will return? I will return the same function, but in which part I need to travel? I need to travel in left part. Okay. Uh, Otherwise, P and Q will be greater than what? Greater than root. Sorry. Oh, greater than root. And here I mean smaller than root. Okay. Greater than root. Then I have to return. Then I have to return right. And that's all. Let's see whether it works or not. Yeah, it works. So let's just do a dry run so that we can have the understanding. Okay. So first when I came to h of 6, I had two options, h of 2 and h of 8. But the problem was P and Q. Okay, not for this. Let's do for this test case. So the problem was P was 2 and Q was 4. Both were smaller than 6. So both were smaller than 6. So we did lowest common ancestor in the left part. So in left part what will happen? We will traverse to the h of 2 thing. So we will do h of 2 now. So h of 2 will give me h of 0, comma h of 4. But the point is, now I have 4 also. Sorry. Now I have 2 also, as 2 can be descendant of its own, and 4 also. Hence I got my answer. So this condition will be triggered. See, this condition will be triggered. So my P is greater than equals to root dot 12 and Q is greater than root dot 12. Okay, this condition will be triggered. Or let me, oh no, sorry. This condition will be triggered. So basically Q is greater than root right now. Right now root is 2 and P is equals to the root. Hence my root is the answer. Hence, what will be the answer? 2 will be the answer. So this was the dry run and we got our answer. Similarly for this, if you do the dry run, my left is 2, my right is 8, means this condition is getting satisfied, and hence my root is the answer, which is 6. Okay, let's submit our code and check whether it works or not. Yeah, it's pretty much works perfectly. This was not a medium level question compared to the lowest common ancestor of binary tree, which is also a medium level question. It is more of easy level question if you did that one. Otherwise, it can be medium level question for you. So this was the approach. Now, what can be our worst time complexity is number of nodes. So O of n will be the worst time complexity, and we are not using any kind of space here. See, no variables are there where we are storing the value, hence we have nothing in the space complexity. Thank you.